So you can see this is a block W standing here on the slant plane, which is inclined at angle alpha. We are trying to push this block upwards with a horizontal force P. The weight has been given as 151 newtons that will be acting downwards. We have to find the force P in the horizontal direction that will start the motion of the block in upward direction. So this is the direction of motion. So we'll have another normal reaction here in this direction, and because the motion is impending towards upward direction, friction will try to avoid that motion. This is the direction of friction. So normal reaction, let us call it as N. Then the friction force will be mu times N, and these are all the forces that are acting here on our object. We will have to assume the direction for X and Y directions. Let us say this is X direction, this is Y direction, and these axes we will use as a reference to form our equations. The first equation we will form as summation of all the Y components of the forces. Now N is acting in the direction of Y, positive, so it is N. Then component of the weight 151, that is in Y direction, is W cos of the angle. The angle being alpha. So this angle over here is alpha, and the value of angle has also been given in the question, that is 34 degrees. So W cos alpha will be acting opposite to Y direction, hence it has to be negative. And P will also have a component in Y direction that is also acting again in downward direction. The angle here is same as this, that is alpha. So the component of P that is vertical is P sine alpha, and of course that is acting opposite to the Y direction, so that is also negative. So the sum total of these forces has to be 0 because the object has not yet started moving. N is not known, W is given as 151, cos alpha is given as 34, minus P is yet to be found, and alpha is again given, so sine of 34. So this is our equation. If we transfer this constant value to the other side, we will get the equation as N minus P sine 34 equals 151 cos 34. Let's call it equation 1. Next, let us take the components in X direction. So when you see in X direction, mu times N, this is the friction force which is acting opposite to X, so minus mu N will come over here. The component of P will be in positive X direction, so plus P cos alpha, and the component of W, the weight, that is in X direction, that will be opposite to X, so minus W sine alpha. So these are the forces, these are the components of forces in X direction. So now of course the sum of all these components also have to be 0 because the object is stationary, it has not yet started moving. And let us substitute whatever values are known. Mu is 0. Okay, mu is given as 0.26 in the question, times N, which is not known, plus P is not known again. Cos of the angle is 34 degrees, minus W is given, that is 151. Sine of angle alpha is also given, that is 34. Let's again send the constant value to the other side and bring it in standard form here. So minus 0.26 times N plus P cos 34. This negative term on the other side becomes positive. So 151 sine 34 degrees. So this becomes our equation number 2. So we can see that in equation 1 and equation number 2, there are two unknowns. The two unknowns are N and P. So equation 1 and 2, they are like equation in two variables, which we can easily solve using equation mode in our calculators. So in calculator, whatever is X, we will assume it to be N for our actual purpose, and the Y of calculator we will assume it to be P. Let us see how to feed this. So on the left here, you can see the calculator app on my mobile, and let us feed these values. Let us start with equation number 1. So we'll have to feed the coefficients. Before that, we'll of course have to change the mode of the calculator to equation in x and y. So here, this is the equation that we have to choose, and here you can see the equation is written at the top, that is in the format ax plus by plus c equals 0. Let us reset all the values. Now we'll have to feed the coefficients of x, y, and the constant. So in the first equation here, coefficient of n, that is considered as x, that is 1. Coefficient of y, y for us here is p, so that coefficient is minus sine 34. So minus sine 34 is equal to record the value, and then the constant on the other side is 151 into cos 34. Let's go 34. Press equal to again to record the value. Now let's come to the second equation. In the second equation, coefficient of n is negative 0.26, and the coefficient of p is cos of 34. Let's put cos 34 plus equal to, and the constant on the other side is 151 into sine 34 plus equal to. Now all the coefficients have been fed. Press equal to once again to get the value of x. Now in the calculator, as I told before, the value of x for us, that is the value of n, and that value, let's note it as 220.87, and press equal to once again to get y value, and y value for us is p, and that we are getting as 171.12. Of course these values are in newtons because all the other forces given here, they're all in newtons. So this here is the answer that we need to feed. Let's feed it and check whether it is correct. 171.12. Let's go ahead and submit. And there it is. You can see that the answer is correct. Exactly. This is how you need to solve, but the inputs that are given here in this question will be different from the ones that you might get when you're solving it on Moodle. Fine. So take those values which you are getting on Moodle, solve using the same process that I've just explained, and then feed the value that you get. Thanks for watching this one. In the next video, we will see another question.